All right. So we were talking about these spherical mirrors, and we did talked about the nature of the images formed by them, right? And in today's class, we were talking about like, do the rays
So
actually come to
can
meet
you
point?
explain like the again this because I left it because the network issues are there and couldn't
Mhm.
hear you, so I left the class.
Okay, look here. In the previous class, we were talking about the two types of mirrors, namely the concave and the convex mirrors. I will be revising them once more quickly. Look here. Concave mirror is the one that looks like this, where the reflecting surface is bent inward like this, okay, in this manner, right? Okay, so the image that will be formed in the concave mirror will be what? Okay, what will happen? When the light rays will struck it, when the light rays will struck it, when the light rays will struck the reflecting surface, then they will actually meet at this point. Okay, forget about this dotted lines. Okay, that will confuse you guys. Okay, so just say here that when the light rays will be coming from a distant object and it falls on a concave mirror, so the light rays actually bounces back and meets at a point, and at that point the image will be formed. Okay, so the image that will be formed here will be real image because it can be seen on a screen. For example, like this here. Let me show you the diagram. Yes, here. Yeah, this one, right? So here the image of the candle is being formed on this screen. And Vaiga, what was the what was the another property of the image? Was it inverted or erect?
So it is inverted.
Inverted. Right now it is inverted. Okay. Top bottom inversion is seen there, right? And the size of the image, generally it's magnified. Generally it's magnified. Okay, in class 9 you will get to see that at different positions, when objects are placed at different positions, then the shape and size of the object of the image form will be changed. Huh? For
Yes, sir.
example, if a if an object is placed very near to the object, okay, if it is being placed here, or if an object is placed at a very far distance, for example here, then then the size of the image or the other properties of the image that will be changing then. Getting it now? So usually in a general way, we say that the image form will be magnified, right? Okay, but there was a condition applied in the case of concave mirror. What happened? Like if you were to bring the image very close to this concave mirror, just like this one, here we have brought the object actually very close to the this concave mirror. Then the image will be formed behind the mirror. The image will be formed behind the mirror. And since it is being formed behind the mirror, it's virtual. I cannot actually obtain in the on a screen, and it will be a erected image also, not inverted. So the thing you need to remember about concave mirror is that it gives a real image, inverted image, and magnified, and the condition applied. Okay. Then we did talked about the convex mirror, which somewhat looks like this. The reflecting surface is bulging outward like this. So the image formed by the convex mirror, it was erect, virtual, and diminished. For example, you have this magnifying lens. Okay, thereby, suppose this is the object here. Sun has been taken as the object. So the light rays coming from the sun will meet at this point. Okay, now, and the image that will be formed will be having a very small size, very diminished in nature, and it cannot
Yes,
be.
sir.
It will actually be a virtual image, right? Okay. So now here, look here. You have got the two curved mirrors, concave and convex mirrors. So in the today's class, we will get to understand how the rays basically meet when they reflect back from the mirror. How do they actually meet and the image formation takes place? Hmm. So look at the concave mirror here. So when the light rays are coming from an object, suppose you might have placed a candle here. You might have placed a candle here. or either there might be a bulb here or a torch here, from which light rays are falling on an object here. For example, there's an object, and then it is getting reflected back and then falling to this concave mirror. Getting it or not, what I'm trying to say here?
Yes, sir.
Like, there will be a formation of image only when there is source of light. So the source of light here is, for example, a torch, right? And there is this object here. So the light is coming from this torch, for example. It could be a bulb as well or any other source of light. Then it will be getting reflected back from the object, and then it will fall on this concave mirror. So in the concave mirror, light rays actually converges at a point. Light rays, in reality, they are converging at this point. It's not like it's appear. Huh? Remember, in the concave mirror, moments ago, I told you that you can obtain the image. It's a real image. It can be obtained on a screen. Huh? So if I were to place a screen over here, then I can obtain the image. If I were to place a screen here, I can actually get a image of the object. Again, have a look at this diagram. It will be more clear then. This diagram you can see here. The light rays, when it got reflected from this concave mirror, its image was actually being formed on this screen, right? So here, the light rays, the formation of the image has been shown using just one line.
Yes,
Okay.
sir.
So don't get confused with that. It's just a pictorial representation, not actual. Okay. So back to the concave mirror, that you have got this reflecting surface and the light rays which are coming, which are incident on this concave mirror. After reflection, they all will meet at a point, and that point is here basically focus, right? F, the point at which they will be meeting will be called as the focal point, the focus point. Okay, is that clear or not?
Sir, it's only
Let me.
focus, right?
It's focus. Focus.
Sir, can you
Yes,
explain
sir.
again?
So can you
Okay.
explain over that?
Yeah, sure. Here, look here. In the case of concave mirror, what happens now? The light rays, when it gets reflected back from the surface. Suppose these two light rays are incident on it. Okay, these two lights are incident on it, and there's okay. Actually, let me tell you a few things regarding a curve mirror. Actually, this curved body, of the curve mirror, we call it as aperture. What do we call it as? Aperture. Okay, now
Aperture.
aperture, right? And this point here, this is the middle point of this aperture. What do we call it? Call it as? We will be calling it as pole. What? Pole.
Oh.
And the line perpendicular on this pole, that will be called as the principal axis. Principal axis. Right now? Okay, now see here. When the light rays will be falling on a concave mirror, it will get reflected back. It will get reflected back like this. The light rays were coming like this and then got reflected back. Okay, and then look at this light ray. It is coming back. It will also get reflected back.
Sir,
Okay.
so if it is coming in a straight way, right?
Hmm.
So then it is reflected by like in another
Hmm.
shape.
If yeah, there are certain rules also. Okay, in higher classes, I'm not touching that point because you guys will get too confused if I were to touch upon the laws of how if the light rays are coming in such a manner, it will get reflected in what manner. Right now, look here, there are different laws. Okay, for example, if the light rays are falling directly over here, then it will get reflected in this manner, right? Or if the light rays were falling on in this manner, it will get reflected back in another manner. For example, it will be getting reflected like this, right? Or in the another case, If the light rays were to come like this, then it will get reflected back in the what manner? So I'm not getting there. We are not here to discuss the things in that detail because that is not part of the syllabus right now. Simple thing you guys need to understand here, look at the two figures here. After the reflection, you get to see, look at the arrows here. No, have a look at the arrows. Okay, it's not working. Look at the arrows here. Is my pointer visible? Is the pointer visible?
Yes.
Not yet. Yeah. Okay. Look here. The lighters are coming here. They are incident, and then they are being reflected here. So all of them are actually coming to meet at a point. While in the case of convex mirror, you get to see that we are drawing dotted lines at the back side of the mirror here. On the back side of the mirror, we have actually drawn the dotted lines here right now. So
Yes.
here it seems as if they are converging. Notice the word seems to be converging. It seems to be converging, but in reality, it diverges. Reality, it diverges. Here you can see it is diverging. It is diverging in the same direction in which it came. It came in this direction, it got directed back in the same direction. It came in this direction and then got diverged back in this direction. Thereby, a convex mirror is called as diverging mirror, where the rays do not come to meet at a point in reality. It only seems to be converging, but in reality, it is diverging. Are you guys getting it or not? Sundus, Vaiga, and Chakrika? Is this
Yes, I
point
got
clear?
it.
So what is the meaning of converging?
Converging basically means to meet at a point. Okay, now converge basically means to meet. Diverging
Okay.
means to move away in a different direction. All right, shall we move
So
ahead then?
concave mirrors like moves away and convex like meets at a point.
In the case of concave mirror, the light rays meets at a point. Light rays actually
Okay.
meets at a point. While in the case of convex mirror, the light rays appear to be meeting at a point, but in reality, it diverges. Thereby, convex mirrors are called as diverging mirror.
Okay, sir.
Okay, Chakrika, why guess in this? Is that clear?
Yes,
Yes.
sir, it's clear.
Okay. So then we were talking about like the two types of image that can be formed. That is a real image and the virtual image. Okay. So we did talk about the difference between the two, right? A real image is the one that can be obtained on a screen, while the virtual image is the one that cannot be obtained on a screen. Okay. So in the case of this image, in the case of this concave mirror, you get to see that suppose this is an incident light coming from an object. Okay, now, and then it is getting reflected back. So say this is an image here. Suppose this is a tree over here from which the light rays are coming. Okay, this is an incident ray falling on this concave mirror, right? And then this will be the image of it formed by this concave mirror. Getting it, guys? This is the image of it. Okay,
No, but
and
then we
this,
need two rays to draw the image, right?
yes, there's no
But
need
we
to
need
draw
two
it.
rays to draw the image, right?
Yeah, exactly. We need actually two
I
days
mean,
to
to
draw the right.
find where the image will be formed.
Exactly. But here to just give a simple representation, I am taking just one ray. Okay, now look here. If you were to look at that thing now, you guys will have to study the properties. For example, what are the properties? For example, again, take this concave mirror. This was what? Principal axis, and that is the pole. Okay, look here. If a light rays comes parallel to the principal axis, then it will get reflected back from the concave mirror and will pass through this focus. This point here will be called as focus. So first law is that if a light ray comes parallel to the principal axis on a concave mirror, it reflects back from this focus. Is that clear? Is that clear to all three of you or not?
Yes, sir.
Okay. Then second law here, it states that
So can you explain the part like from where like the ray reflects back from the mirror?
here
So
now.
can you explain one more time?
Okay, this is an incident line, that incident ray falling on this concave mirror from here on this part here, and from here it will be getting reflected back, and then it will pass across the principal axis, and the point where the principal axis and this reflected ray is meeting, that will be called as focus. 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 Getting
Okay,
it now? That is focus point. Is that clear, Sundus and Chakrika?
yes, sir.
Second law basically says that if a light rays is coming like this, if it falls at a degree of 90 degree, okay, if it's uh, falling perpendicularly to the concave mirror, it will reflect back in the same direction. Is that clear? Is that clear?
Yes, sir.
If a light rays falls perpendicularly at an angle of 90 degree on this concave mirror, it will reflect back in the same direction with the same angle. So angle of incidence and angle of reflection both are 90 degree here, right? Not 90, yeah, 90. Okay now. Okay. And then if you were to look at this here, the third law here. The third law says that if a light rays falls on the concave mirror passing from the focus, then it will return back parallel to the principal axis. Getting it? Is the three law clear to you guys or not? Let me repeat this one again. If a light ray,
Sir, but then the third law and the first law aren't the same.
exactly, they are same. It has only got to do with the direction of the incident light coming on it. If the incident light is coming parallel to the principal axis, it will be getting reflected from the focus. It will be passing from the
Okay.
focus after reflection. Or suppose if it was falling on the concave mirror, coming passing from this focus, then it will be reflecting back parallel to the principal axis. So if these three
Okay, sir.
laws are clear, then this can be more, it can be understand more easily. Say this is the focus point here. So earlier this light ray was coming on it, and then it got reflected back passing from this focus, right? And then you get to see like there will be two light rays actually that is needed to form an image. In order to get an image, we need at least two light rays. So this is the light ray number one, and this will be the light ray two, right? That is actually falling from on the focus. Getting it now? So we know that if a light ray falls on the mirror from the focus, look, it can be drawn either ways as well. We can draw it like this as well. Okay, if it were to come like this, it will be getting reflected back. It's the same thing. It's the same thing. Whether I draw this diagram or whether I draw this diagram, the only difference is whether it's falling from below or whether it's coming from upward. Here it's coming, the incident ray is above the principal axis. Here the incident ray is below the principal axis. Now back to this here. This incident ray that is passing from the focus will be getting reflected back parallel to the principal axis now. Yes. It will be falling.
What, sir?
Okay, let me
Sir, can
repeat
you
that.
repeat again?
Yeah, sure. Look here. This incident ray is falling on the concave mirror and it is passing via this focus, right? So it will return back
Yes, sir.
perpendicular to the principal axis. Now this Line here
Yes,
that
sir.
you are seeing, that is the principal axis.
So that is rule 2, right?
That is rule number 3. Rule number 3 here. Okay, there's no order of the rule. Simply it's one of the rule. Okay now.
No, sir. Like while drawing
Hmm.
the parallel line, the parallel line is like I mean, not the parallel line, the perpendicular line is like the second law, right?
This principal axis. No, look here.
Like
We
not
are
that
here.
one, sir.
Look here. Look here. Here, when you take this line here now, here when you take this line, it is coinciding with the principal axis. If you were to look at it, it is actually coinciding with the principal axis. Getting it? What I'm trying to say here. The light ray, the line that passes from the middle of the aperture, from the middle of the concave mirror here, that is actually principal axis. And suppose if the light ray is incident on it coinciding with the principal axis, then it will be getting reflected back in the same direction. But here, this light ray that is incident on the concave mirror, it's actually parallel to the
Yes,
principal
sir. Yes,
axis
sir.
and not
Yes, sir, I get it.
overlapping it, not on it, not coinciding with it. You guys are getting it now. So that is the thing here. And then
Yes,
look
sir, I
at
get it.
this light ray. It is passing via this focus and then getting reflected back and then and then returning as parallel to this principal axis. So here you can actually meet these 2 points. You can actually meet the 2 light rays, meet the 2 reflected light rays. So thereby you will be getting this image here. So here we get to see that the image form is inverted, right? And it is
Yes, sir.
real. That is, this image can be actually obtained on a piece of screen. Getting it? Okay. In higher classes, you will get to know that there are different positions at which images can form. Like if I were to place an
Sir, within
image. Mhm.
in our class, ma'am already taught us the cases, sir.
Okay, you haven't already been taught the cases. Okay.
Yes, sir.
Okay. What about you, Vaiga and Chakrika? You guys are following NCERT textbook or not? In your school is
Actually, sir, I said I'm Chakrika, sir. Who says that I have already learned? I was the one who said that.
okay. Okay. You said you have already learned, completed the chapter. So
Yes, sir.
in your school, NCERT is being followed or different book is being followed?
No, sir. It's a bit different.
It's a bit different, no? Huh, that's why. Okay, because usually in class 7, NCERT is not including those topics right now. Hmm.
Okay, sir.
Okay, okay. So we can discuss that, or for you, I can discuss that. But then, Vaiga and Sundus will be having difficulty then. Guys, please do check that. Please do confirm that from the NCERT. I don't have the NCERT book right now of class 7. Otherwise, I would have checked it myself. But I'm sure that it is not in the part of the syllabus. Okay now. So thereby you will get to see now that with different position, the nature of the image formed by concave mirror changes. If I were to place it too close here, between the focus and the pole here, if I were to place the image object here, then the image will be formed here behind the mirror. It will be formed behind the mirror over here right now. Anyways, we are not going there, right? So image, as I said, it could be of 2 types: real image and virtual image. So the differences between them were also clear, and the real image can be obtained on a concave mirror, while the virtual image can be obtained all 3 of the plane, all 3 mirrors, whether it's a concave, convex, or the plane mirror, right? So Sundus, Vaiga, and Chakrika, do tell me, in order to get a virtual image in the case of concave mirror, where should the object be placed? At a great
Uh,
distance from the. Mhm.
Sir,
Yes,
it should
What's
be
up?
placed very near to the mirror.
very near to the mirror, right? I was saying, no, Vaiga, in order to get a virtual image using a concave mirror, where do we need to place the object? It has to be close to the mirror, or it has to be at a distance from the mirror.
Closer.
Hmm. It has to be a. It has to be very near, no?
Yes, sir.
Getting it now? Okay. Okay. These are the properties which you have already covered. The images formed by convex mirror and the concave mirror. Application of concave mirror, right? Now, since a concave mirror gives you a what kind of image? Since concave mirror, it is actually converging the
So
light
with the,
rays. And then, yes,
So it gives a
so
virtual image,
usually
right?
concave mirror gives us like both virtual and real image, right?
yeah, both virtual and real image. Yes,
So like, do we consider the real image more or the virtual image more?
no.
But
In
vertical, right?
most of the cases of concave mirror, now for most of the position of the object, you get a real and inverted image. You will be getting the virtual image in the case of concave mirror only when the object is put very close to the mirror. This is suppose object here. This is an
Yes,
object
sir.
here, right? So when you will place the object very near to this concave
No, sir.
mirror,
Like,
mhm,
which one do we consider more, like the virtual image or?
we consider both of them. When we talked about concave mirror, no, usually you will have to define like, yeah, the image formed by concave mirror for most of the cases it's real. While if exception is there that when the object is placed very near to the concave mirror, then the image form will be virtual. So while defining it, it's better if you were to include the exception in the definition also. Right now,
Okay,
is
sir.
that
Thank you,
clear?
sir.
Okay, right. Okay. So if you were to place it to here, then the image will be formed here, as I said, right? And that will be virtual actually. Now, application of concave mirror. What are the applications of the concave mirror? Where do we use it? Quickly. Hmm.
Sir, as a shaving mirror.
As a shaving mirror, it can be used, or dentist also use it, or shaving as a shaving mirror also it can be used, right? And the satellite dishes you must have seen. It's also a shape resembling a concave mirror. Satellite dishes you must have seen that, huh?
Yes, sir.
Hmm. So satellite dishes are also having a similar shape. So basically, a satellite dish that looks like this, its work is to collect all the signals on a point. So it will be gathering all the signals, getting it now. All the signals that is coming from the satellite, this satellite dish will be gathering all of that at a point. Okay, and then might either reflect it at a certain point to any other source, right? Then you have say dentists also use this type of mirror. Shaving mirrors are also having
So
concave.
like makeup
Hmm.
mirror.
Makeup mirror or shaving mirror. Okay, both of them have the concave mirror in it, right? Headlights of a car you must have seen, that is also having a concave mirror so that it can
Yes, sir.
reflect back light in a straight path,
Yes,
right?
sir.
Okay, torches, this torch here, it is also using a concave mirror. Getting it now?
Yes, sir. Got it.
Okay, then talking about the application of the convex mirror. So convex mirrors, you see the rear view images, the rear view mirrors actually, that is installed in the real view mirrors that is installed in the vehicles that are actually convex mirror. Because as we know that the image formed by convex mirror is actually diminished now. Hmm?
Yes, so like sir, also shop security mirrors, right?
Exactly. Shopkeepers also equip it at the corner in the shop so that they can have a synaptic view of the shop right now. So it can be a cheap alternative of a CCTV camera right now. Okay, so security mirrors in the shops or in the ATMs are also the convex mirrors right now. So they can easily detect if anyone is there or not, right? So that is all about the mirror. In the next part of the chapter is dealing with the lenses, right? So lens is what? Lens is simply a material like a glass or a plastic, okay, that is curved from both sides. In the case
So
of
like it is made up of a transparent material.
Yeah, it has to be made up of a transparent material. Exactly. It has to be made up of a transparent material. That is correct. But the thing about the lens is that in the case of
Uh,
mirror, we were seeing that the reflecting surface is on just one side. Okay, either it be on the outer side or on the inner side. But
Yes,
in the
sir.
case of lenses, we see that the material is curved from both the sides right now, or it might be either curved in this manner or it might
sir,
be
but then
curved
this
in
is
this manner.
convex lens, right? And this is concave lens.
Yeah, this one here, the first one which I have drawn here, that is actually a convex lens. Convex
Yes,
lens.
sir.
And that one here is a concave lens. Okay, you can actually do its comparison. You can actually do its comparison with the concave surface and the concave lens and the convex
Sir,
concave mirror and the convex mirror. Yes, Chukrika.
sir, it's usually said the concave lens are just, I mean, the concave mirror is just like convex lens, and then the convex mirror is just
Hmm.
concave lens. Is it true?
Not exactly true. Look here. When we talk about the concave mirror, it's like this right now, and that is the reflecting surface here. Okay, this here is the reflecting surface. Okay, so that was a concave mirror exactly. And there, in the case of concave lens also, I am seeing that the reflecting surface is bent inward, right? It's bent inward. And in the case of convex mirror, basically what property moments ago we discussed, that whether convex mirrors are converging or diverging. Convex mirrors, they are converging
Diverging,
or
sir.
diverging. They are diverging. Yeah.
Diverging, yes, sir.
And the concave mirror are converging, right? In the case of convex lens, now the magnifying glass example which I gave you, what is that? That is nothing but consisting of a lens in it now, and it actually consists of a convex lens in it. So when
Yes,
the
sir.
light rays passes via a convex lens, all the light rays converges to a point, right? So thereby convex lens are called as converging lens also. These are the converging in it right now. So we say that all the light rays, since it's converging at a point, thereby convex lens will be converging lens. While the concave lens, look here, when the light rays will be falling on it, when the light rays will be falling on it, it will be diverging. It will be diverging. Getting it now? So thereby we say that concave lenses are diverging. While then, look here, this concave lens and this concave mirror. Concave lens and concave mirror. In the case of concave mirror, moments ago we saw that the light rays were actually converging now. The thing here is that concave mirrors are converging. Concave mirror are converging while concave lens are diverging in it. Diverging in nature. Is the point clear or not? Yes? Are you guys getting it?
Yes, sir.
Yes, sir.
Is Sundus in the class?
Yes, sir, I'm in the class.
Yeah. So right now we are talking about the lens. So lens is simply a part of the reflective material like glass or plastic, but it is curved on both the sides. Right? Now, you will get to see that apart from the convex lens and the concave lens, you can have these lenses in combined form also, right? You might have actually seen that um, the glasses that we made earlier, okay, so it had a shape like this in the middle. Hmm? Have you seen that?
Sir, but then some glasses don't, right?
The glasses that are made nowadays, they don't have. Okay, now getting it
Yes,
now.
sir.
Okay, so basically,
Yes, sir.
convex lens. If you were to talk about the convex lens here, look at it. How all the light rays are converging at a point here, right? So thing about convex lens is that it is curved outwards, and if you were to look at the center of it, it is thicker now, right? So it is thicker in the center and narrows down at the edges. At the edges, it starts to narrow down, right? And whatever light rays will be passing through it, it will be merging, it will be converging those light rays at a point. Therefore, it is called as a converging lens as well. And what are the nature of the image formed by it? The image formed by it will be real, inverted, and the image is large and appears close to the lens. So thereby, magnifying glasses are used to get a magnified view of object because it forms a magnified view of the object now. Getting it?
Yes, sir.
Right? Okay. So the points, you just need to remember them, right? Just remember the points. And then talking about the concave lens. So concave lens, also known as the diverging lens, right now. So here the reflecting surface is bent inward like this. As you can see here, it's bent inward. So in the med, it's thicker, it's thinner actually, and the edges are actually wider here, right? So it will be reflecting back all the light rays that travels through it in different directions,
Sir,
as
can you
you can see
explain
here.
again?
Yeah, sure. Regarding the concave lens here, you can see that the reflecting surface is bent inward like this. Just in the concave mirror, the surface was bent inward. Okay. And all the
Yes, sir.
light rays, when it passes from the concave lens, it will actually diverge in different directions. And the light rays are actually passing through it. While in the case of the concave um, mirrors, the light rays appears to be passing in the case of convex mirror. If you were to talk about the convex mirror for a while, look here. When we were talking about this convex mirror now, we saw that light rays appear to be passing from it and then meeting at a point. Yes, that's why we have drawn dotted lines here. When we were talking about mirrors, whether it's the curved mirrors or the plane mirrors, right? Especially in the case of convex mirrors, the light rays are, you can see, they are diverging in different directions. Thereby convex mirror is also called as diverging mirror. But when I were to draw the pathway of the reflected light rays further, and then when I try to meet at a point, here I'm seeing that it appears to meet at a point, and it actually appears to have passed from the convex mirror. But in the case of a lens, the light rays are actually passing from the material of the lens. Are you guys getting into what I'm trying to say here?
Yes, sir.
So there's an actual passage of light rays in the case of concave lens, while in the uh, case of mirror, it's not really. Okay, in the
Okay.
case of concave mirror, the light rays are actually meeting, but in the case of convex mirror, the light rays are not, right? Okay. Then talking about the properties of the concave lens, what type of image it will form? It will be forming a virtual, erect, and a small image of the object. Have a look at the two lenses and have a look at the image formed by them. So in the first one, that is a convex lens. So as I say that convex lens will be forming, look at that, this dotted line, which dotted representation here is the image of the fly. Okay, now. So convex
Sir.
lens, as we know, yes,
So, sir, in convex lens, it's real. I mean, virtual image, right?
in the case of convex lens, no,
Yes,
it
sir.
forms a it forms a real image now, not a virtual image.
Convex
So,
lens.
so
I
in
mean, sir,
concave
lens.
mirror,
Convex lens.
so in concave mirror, it's a virtual image.
In the case of concave mirror,
Yeah, in concave mirror, it's virtual.
yeah, when you bring the image really close to the lens, then you will be getting a virtual image, right?
Okay, sir.
In the case of concave mirror, we had actually discussed the case that when we were to place the image between the focus and the pole, then the image of the object is formed behind the concave mirror, and thereby it was virtual and erect. While in
Yes,
other
sir.
all the rest cases, it will be always real and
Sir,
inverted. You
I
will
was
be able
asking
to
for
operate
the
on the
lens
image.
actually.
Yeah, I thought that. Okay. So will you
In
please repeat your
convex
question?
lens, it's virtual, right?
In the case of convex
So in the case
lens,
of like yes, sir, convex
Hmm.
lens, it's virtual, right?
No, it's real actually. In the case of convex lens, it is real, it is inverted, and the size of the image is actually more. Okay, now it's large. So
Okay, sir.
look
Yes, sir.
at the example now. Look at this, that simple example of magnifying glass now. Hmm. So in the magnifying glass that uses a convex lens, obviously, right? So magnifying glass that uses a convex lens, or the shaving mirrors, not the shaving mirror actually. We are not talking about mirror. Let's stick to the lens here. So in the convex lens that is used in the magnifying glass, we are getting a large image of the object, right? Okay. And for example, if you were to use this convex lens to get the image of the sun, so thereby you can actually obtain it on a piece of paper now, right? So thereby we say that, yeah, the image formed by convex lens is actually real. Okay, actually real, not virtual. And the image,
Yes, sir. I get it.
getting it now. So then here also the condition is applied. Like if you were to view an object that is uh, at a very large distance, for example, the image of the sun that is formed, that for example, the image of the sun that is formed using a convex lens, that is actually real because that can be obtained on a piece of paper, right? So whenever you place a magnifying glass over a piece of sheet of paper in sunlight, so you get a bright spot on the paper and paper starts to burn. So that is actually the image of the sun, and actually it's a real image because you got it on the paper. And it has been said, and it is actually true, that it is inverted. Okay, since the light rays are coming, the object has been placed at a great distance. Now as the object is moved close to the
Sir,
mirror here, to the lens here, then the image will be virtual. That's why yeah.
so they say that if we do that with the convex lens, then the fire will be caught. Like, I mean, the paper
Hmm.
will be burned, right?
Exactly exactly that actually
So why?
happens.
Why does that happen, sir?
It actually happens because the sun's rays that are passing through this lens now, suppose, look here,
So parallel rays, right?
parallel rays, exactly. Let's take this example again. Say this is a magnifying glass that is having convex lens. And convex lens, we know that they are actually converging now. They converges the light rays. Suppose whatever light rays are coming from the sun, they have energy in them. Yes, they have energy in them, right? Now you suppose one, two, three, four, just to take an example. Okay, just to take an example, I have taken four sun's rays, and then they are going to pass through this plane mirror, sorry, through this convex lens, and then they will be converging at a point. Okay, so now this will be having some energy, this will also be having some energy, some energy, right? And what that energy will be, that energy will be in the form of heat now, right? Now that's why we feel warm in the summer season now, because there is sun's rays are bright in the summer season, right? So sun's rays are having energy in them. That energy is basically heat in them. So imagine four light rays where separate from each other. For example, now they have converged at a point here. So all of their energy will be combined here. No, it will be 4E here, for example. So that's why that much heat of the light rays has been accumulated at a single point. That's why the paper starts to burn. Is that clear?
Sir, I do not get it.
Okay, look here. Let me explain this one more time. Why guys, is that clear to you? Or Sundus, is that clear to you? Okay. Basically, what is happening now? The light rays coming from the sun. What type of energy it consists of? We know normally it's consists of light and heat in it, right? Agree with this point or
Yes,
not?
sir.
Yeah. And then I say that just in a hypothetical manner, I have taken 4 light rays. It's not the way how the light rays actually passes. It's not like the 4 or 5. You can't actually count the number of light rays. You have just hypothetically taken 4 light rays coming from the sun are passing through this lens here, and all of them will be having some amount of heat in them. Is that true or not, Sundus, Vaiga, and Chakrika?
Yes, sir.
Yes.
Yes, sir.
So say each of them were having E, and E as heat. Now, when all of them combined at a point, so now the total amount of heat at that point will be 4E now. It will be 4E. Getting it?
Yes, sir. I get it now.
That's why the paper starts to burn, right?
Okay, sir. Yes, sir. I
And
get it.
get it? Very good then. Now, back to what I was saying, that convex lens here will be forming an image that will be actually real, meaning that it can be obtained on a screen, right? It can be obtained in a wall on a paper. It can be obtained, or it will be actually inverted, right? If the object is like this, the image form will be like this. Is that clear? Okay. And the image is actually large. Large image is formed using a convex lens. Now, shall we discuss about the concave lens then? Yes. Look at the concave lens. What can we conclude from the given figure here? Look at here. This here is the image. The first thing comes to mind that, yeah, the image is actually small, right? And then the image here is actually erect in nature. It's erect. It will be erect actually. Okay. And the third point about the concave image formed by concave lens, it's that moments ago we discussed that it is actually virtual. So the image here will be virtual, erect, and small. Remember these points regarding the virtual lens, sorry, the concave lens, right? Is that clear to all three of you? Yes.
Yes, sir.
Yes, sir.
Okay now.
Yes, sir.
So that is all about the different types of mirrors and lens we have. So quickly, let's start to revise from the plane mirror. In the plane mirror, we got to see that the image form was actually virtual, of the same size as the object, right? There was lateral inversion, sideways inversion was seen there, right? Now from right to left, or right to left, from right to
Sir,
left,
we
or
don't
left to
have
right.
like light calculation, do we?
Light calculation. Okay.
Yes,
In the
sir.
yeah, we will be solving few numerical questions. There will be some calculation based questions. Okay. Right now, we will
Sir,
just
like the angle of incidence and the angle of
reflection.
reflected ray. Yes, sir.
Yeah, regarding that, we will be discussing few questions. Okay, now. Okay. As in the beginning of the class, we did solve 1 or 2 questions related to the angle of incidence or angle of reflection.
Yes, sir. Yes, sir. Yes, sir. I remember.
Right now.
Yes.
Okay. And then we were talking moments ago about the spherical mirrors right now. So the spherical mirrors are basically the concave mirror and the convex mirrors, right? So in the case of concave mirrors, also called as Converging or diverging?
Converging.
Converging.
Converging mirror, right? So the reflecting surface was bent inward, and the light rays are actually converging at a point, right? It's not like if it's appearing, it is actually converging at a point. So that was the concave mirror, and the image formed by the concave mirror was actually real, inverted, and much smaller than the object. Then we did talked about the concave mirror, right?
Sir, isn't it magnified?
Which one? Yeah, magnified, exactly. Virtual, erect, or magnified.
Sir, but then
The
like there are three cases, right?
glasses are like convex.
They can be
Mhm.
magnified or
Both has to
same
be.
size or small, right?
Exactly. It could be of the same size as well, right? When it is placed at center of curvature. Anyways, so regarding the cases, usually it is smaller than the object or of the same size as of the object. But if the object is like kept real close to the mirror, then the object will be virtual and then magnified, right? And erect as well. Then uses of concave mirror, we talked that dentists use that, okay, or as a um, shaving mirror, it can be used. Then convex mirror. Another name for convex mirror is what, Vaiga?
What's up?
Yes. Convex mirror is also known as
Diverging mirror.
diverging mirror. Okay. And the reflecting surface of the convex mirror is this one or this one? The reflecting surface of the convex mirror.
Since
So
one.
it's inside.
It's one now. The reflecting surface is bulging outward now for the
yeah.
convex mirror, right? Okay. And we saw that the light rays which are incident on it, it appears as if they are meeting at a point.
Yes, sir.
Okay. So thereby it's getting diverged from from different lens in different direction, right? We did talk about the images formed by the two types of mirrors, and we right now we were talking about the different types of lenses, that is the convex lens and the concave lens, right? Now, like in order to fix different eye problems, these different lenses are prescribed, right? So there are different eye related problems. For example, some person are able to view distant objects clearly while someone is not able to see the nearby objects clearly, while someone is able to see neither of the neither of them clearly, right? And
Yes,
with
sir.
old age, people develop different problems, different conditions in their eyes. For example, cataract problem is there, presbyopia is there, right now. So in order to fix the different eye problems, what types of lens are prescribed, we will discuss that also for a few minutes in the next class. Okay, not in detail, but to cure short-sightedness, if a person is able to view only the nearby objects and not the objects at a great distance, what type of mirror is prescribed, and in what manner the mirrors actually cure the problem. Getting it now? So that
Okay.
we'll be covering in the next class then. Okay.
Okay, sir.
Now, the thing here is that the white light or the light rays that is coming from the sun. Okay. Light actually does not have a white color, but it appears as if it is having a white color, right? It appears as if light is having a white color, but in reality, it's not actually white there. So you all might have noticed a rainbow. It usually appears after the rain. When the sun is low in the sky, you must have seen that
Rainbow.
rainbow. So
Yes,
basically,
sir.
an arc of 7 colors is seen in the
So
sky.
this is
And
dispersion, right?
yeah,
Picture.
No, dispersion, right?
dispersion. Yeah, there's a concept of dispersion involved in it. Okay, we will get to understand that as well. That is basically in the year 1665, Newton discovered that he discovered using his glasses like this. Newton in the year 1665, he basically did some experiments using these glass prisms. Okay,
Yes,
so
sir. Picture.
exactly, Vibgyor was obtained using this right now. So
Yes, sir.
he basically said that sunlight is made up of a mixture of lights of 7 colors. And Isaac Newton, basically he found out that when a beam of white light is passing through the prism, then the white light splits to form a band of 7 color, as you see here, right? Also called
Okay.
as a spectrum. Okay. Like all the colors, in short, for violet, indigo, blue, green, yellow, orange, and red, in short, we call them as whip gear. Okay. And when you obtain this whip gear on a screen, then it is called as a spectrum. Okay. So that we'll be discussing in more detail. All this, how rainbow formation takes place. Okay. What are the concepts involved in the formation of rainbow? How the light rays are actually getting reflected when it passes via raindrop? How then reflection takes place? Getting it now? So all those things we'll be covering in detail in the next class, right? Okay. Any
Yes, sir.
confusion so far?
No, sir.
No, sir.
Okay. Which lens is called as diverging lens? Concave or convex?
Concave.
Concave.
Concave lens are called as diverging lens, right? Okay, good. Okay, so where should I be using this concave lens? In a torch? In the headlight of the torch, should I be using this? Yeah,
Yes, sir.
Yes,
right?
sir. I guess.
Because if you were to look at inside of the torch, suppose this is the bulb, okay. And also if you were to look at the surface, this is the actually inside surface. Okay, now suppose this is the reflecting surface. If you have seen the old torch, nowadays they don't make such torches. Okay, so we know that in the case of concave lens, the light rays actually diverges in this manner. No? It diverges in this manner, not this light. It diverges right now. So in the case of torch also, we want the light to spread